Yeah, all right, very good. My name is Arkadiusz, for short Arek, and I work with Esri. And I would like to invite you today to my presentation about how the extreme heat has become the huge problem for the cities, and how we can help cities to understand and eliminate any opinions and look into the brutal facts, because this is very important to start action and acting on that. Before that, I need to start a story about what is reality mapping. Reality mapping capabilities at Esri are powered by ArcGIS Reality Suite. But to explain you what is reality mapping, I would like to tell a story I told to my son. 1 year ago, I was picking up from school. He was 7 years old, and he was really angry. And I asked him, "Why you're angry?" And I said, "Today I had to stand in front of the entire class and explain what my parents are doing for a living." "Oh, what did you tell them?" I said that you are sitting in front of the computer, talk English and travel a lot, because I don't understand what you are doing. So I told him, "Hey, you were born," I couldn't explain to him principles of the photogrammetry or imagery, right? So I approached this from the perspective, you were born with two eyes. You were born with these two eyes for a reason. And you were born with a very powerful computer, your brain. Your eyes act as a camera. Each eye is capturing an image of the world, and your brain computes this in the real time. All so you can play, so you can kick the ball, and you can understand reality. You are reconstructing reality in the real time. You are texturing this with the color. And what I'm doing, we are trying to replicate what nature gave you with eyes and the brain and put it into the GIS software. So everybody who works with our software can understand what he's looking at. And there are different terms. There is a reality capture, reality mapping, reality modeling. We have chosen to use the reality mapping because we want to be closer to the maps. We are in the map making business. And it all begins today with the sensors. There is multiple sensors capturing and observing the Earth. And we are really betting on being hardware agnostic to consume satellite, aerial, or drone imagery, so any user can bring any type of the imagery. And those imagery are processed, and we are producing products like true orthophoto, point clouds, meshes, and digital surface models that are used later and the whole concept is that we want to bring this base map, 3D base map, that is used together with the other GIS layers, and overlay all the analysis on top of it to eliminate any confusions about what's in between the lines and the points in the standard GIS workflow. So we look from the perspective of the GIS market has been always concentrated downstream. The users were aggregating layers, vector layers, and building their maps. With reality mapping, we want to extend the portfolio to do a seamless integration with any of the imagery and remote sense data, all within our ArcGIS platform. And why we do this? We do this because we really believe that from any imagery, through reality mapping and digital surface model and true orthophoto, a new era is emerging, an era of automated mapping and a mapping that can provide very fast, high-quality insights. That traditional stereo mapping and manual mapping will be replaced sooner or later with the GeoEye mapping, but it all depends on the high-quality imagery. And then when I tell to my team always, like, we are on the mission to bring an imagery and the photogrammetry to 10 million ArcGIS Pro users. Today, very few of them is using this technology, but we need to bring it and put it in the context that they understand. And a lot of GIS users or people using GIS, they think from the use case perspective, how can I use it for my city, for my nation, for my organization? So we identified that there is a huge problem with a lot of the cities. And the city starts to overheat. We have a huge problem, and there is a fact actually that I learned yesterday. According to the WHO, last year, more people died because of the heat in cities in Europe than people were shot in US. That's a very brutal fact, but it puts a little bit in the perspective. So we start looking into this, okay, what we can do about it. And then we identified one of our customers, City of Phoenix. As you know, in Arizona, it's very hot in the summer. We looked into the population data. This is a growing city. And this city, of course, it has a heat problem and overheating of the city. So what we looked into is the first thing where we look is then the imagery data, that freely open data, which is, for example, Landsat, the longest operating satellite that has a multispectral resolution and also has the long temporal resolution because it has been operating for so many years. But the problem with the Landsat is that it's 30-meter resolution, so very low spatial resolution. But Landsat allows us to identify through the thermal channel that there is really a problem with the heating, and we actually looked into the many decades of the analysis, and what you see is the temperature is rising over the decades. So the average temperature in the city of Phoenix is on the rise. So then, of course, we brought this Landsat data into the GIS software and start analyzing all the channels. And very quickly, we and our customer using our software realized that, okay, this spectral resolution, the heat can be mapped, but I don't see the details. You can see this big blue area. We will come back to this. I wonder if you can guess what it is right now. Guess in your head, and it will be presented in a moment. So to go through there, we partner with some of our partners and done a proof of concept over the city of Phoenix with dual installation of the high resolution RGB camera also with the near infrared channel and the echo mapper, which is a thermal camera. It has been done as an aerial survey over a part of the city, and and the concept here is to create a foundational data that has high spatial resolution and high spectral resolution. We have a 6-band, and all was captured simultaneously within one flight. And then we process this data with our reality mapping capability software. We produce all these products, which is short of auto DSMs, point clouds, meshes, and thermal orthomosaics. And then I will get it in a moment to show you. But first, let me show you the examples. So we are right now. Okay. Yeah. We are right now looking on the true orthophoto of the 3 and 3.5 centimeter resolution over the city of Phoenix. And yes, as you understand, the true orthophoto is corrected with the leaning effect. So when we compare this with the satellite imagery, you see that tall buildings are leaning. That's a very important definition to understand, that our tools are focusing on producing true orthophoto that is a pixel-accurate orthomosaic with the position of the GIS data, but also elevation data like digital surface models. So those are the first products, true orthophoto and DSM model that was used. Then, of course, we produced the 3D mesh model with the city of Phoenix just to show them the capability of the 3D perspective. This is a super high resolution mesh with 3.5 centimeter. And what you see is already here that city started recognizing and doing this canopies for the shade for some of the citizens. And what we see here also, for example, 2 different parking lots, one with the shading with the roofs and one with very open in between. So, okay, and then the next product was the thermal mosaic. Because we have done the simultaneous data acquisition, the thermal orthophoto was extremely well aligned with the RGB or true orthophoto. The shadows are exposed and visible exactly in the same position. And that delivers a very strong value for the analysis, because when we do a GeoAI and feature analysis, we have actually 6 bands here if we include the infrared. We have all the bands aligned perfectly in the pixel precision. So what you see, I'm swiping between the RGB and the thermal resolution, and the shadows are aligned very well between the two orthophoto mosaics. Okay. Of course, we can, because we are in the GIS application, we can read each value of the pixel, either it's a thermal or the RGB pixel. So these products, we call them foundational products that are brought into the GIS, but the goal for us is to create a shared understanding. Because for the decision makers, we need to build the trust for them, that they can trust that, okay, there is a problem, we need to act, but where we want to act first. So this is where power of GIS comes very handy. And to do that, we introduce this digital twin curve to them. So the first foundational level at all your digital twin journey is always creating a digital models. You cannot have a digital model before you have a digital, you cannot have a digital twin before you establish a digital model. So we established we call it descriptive layer with the foundational and the cornerstone of the reality mapping. Then the next level of this evolution is where the users are able to collect some of the information. So you can put IoT sensors, you can extract features from it, you can do the analysis. But only after you build these two layers, you are able to actually elevate and grow to the fully true digital twins that are where you can run the scenario-based modeling or any simulations and forecasting. Your digital twin highly depends on the quality of your digital model and the descriptive and information layer. So they agreed with us, and we are still on the journey on this because we just finished the proof of concept, and this journey will continue. But all of this would not be possible without the imagery and remote sense data processed as an input to the workflow. So let's go back to the city of Phoenix, and I will show you now some of the capabilities. So first is the full automatic extraction of the buildings. Because we have a true orthophoto and the DSM model, we were able to map automatically all the buildings with the GeoAI algorithms. So of course we can bring in existing cadastral data if they exist, if we trust that they are up to date, but with the new imagery and high resolution imagery, we can also map them automatically. Then we computed an NDVI based on the infrared true orthophoto, and we have a very good quality information about the vegetation. And using the DSM model in the combination with true orthophoto and NDVI, we are able to extract vegetation. So we are able to segment vegetation. And please notice that vegetation was segmented only above the ground level. So we didn't catch the grass, we catch only the trees that are standing, because the trees cast shadow, and the trees also are very important for fighting the urban heat. So this way we created a vector layer fully automatically with just few clicks. The next analysis that was performed was like a time series of the shadow analysis for the user. So of course, when we have a accurate, the mesh provides you additional context where allowing you to easily interact with the data in the way that is not possible in the 2D. So like performing a simple visual shadow analysis, but also you can compute it and present it as a feature layer that shows exactly how much shadow time, total time per day you will have in a specific location. And here is a simple app also where we use the side rendering of the thermal imagery. By adjusting the temperature slider, the user is able to quickly cut the histogram and show and remove the coolest pixels or the hottest pixels and isolate, for example, a pavement. So by using the thermal orthophoto, we were able to separate immediately all the pavement and the asphalt because that was overheating a lot in the city. And this can be automatically then digitized into the feature layer. So that's a side feature for the user to have a road network or the pavement network as a vector feature. And here we are back to the location where there are these canopies already created by the city, and we immediately see that the temperature is lower in this area. And the last, but not least, is the thermal 3D mesh. So once we created the 3D mesh and the thermal orthomosaic, you can drape it on top of the mesh. And because we have a simultaneous data capture and simultaneous data production, everything aligns very well. So the shadows, temperature of the shadow, and the shadow created by the analysis will align very well. And of course, in this case, we are simplifying to the 1 meter hexagonals, and the user is able to interact with the mesh by clicking and seeing where is the higher temperature and lower. So this takes me a little bit to the perspective. So we created a very high resolution spatial, temporal, and spectral snapshot of the city, all in case to create and then brought it to the enterprise GIS system. So the user can now overlay their other existing GIS data, like census data, where people live, where people work, how people travel. And then we are now on the way to connect IoT sensors to have a real-time sensors about the temperature in the city and other open data, all in case because we want to create multiple twins on top of that foundation. Urban planning is just one of the use cases. But where we're going with this is that when city is investing in the high resolution and spectral data as a foundation and is able to connect it with the GIS data, it's not anymore about building one twin. It's about rebuilding a strong foundation that many things can grow from it. So this takes me a little bit to the final conclusion. So we really right now we are on the mission to promote thinking end-to-end solution, investing in the high quality imagery and input data, bringing it into the workflow like reality mapping, build your content, so increase your temporal resolution, use it for the data analysis and the visualizations, all in order to help the city municipalities and decision makers to act on their city. So the real change isn't in collecting more data, it's in converting it into the impact that leads to action. And we don't really fight heat with colors on the map here. We try to fight it with clarity and coordinations and the courage for the politicians and decision makers to actually trust, based on the factual information and the data, that they need to act and where they need to act first. So thank you, that was my presentation, and you can, if you take the picture, you can test your demo apps, our demo apps with some of the small snapshot of the data. And there is also a very good OGC blog article about how cities fight and beat extreme. OGC is the Open Geospatial Consortium, so independent from Esri or any other software or hardware providers. So thank you for the opportunity, thank you for your time.